Good afternoon, students. Welcome to session. Myself, Naresh Reddy, and I'm going to take this session GTQ, the gate through questions, and I'm going to take up communication system for you. And exam is very near for you, and I'm going to take up likely questions. Okay, the model of questions we can expect in the gate examination. So I'm not going to guess the questions. I'm not going to tell you what exactly the questions you will get in gate examination. So I'll just tell you, okay, uh, with how much difficulty, what will be the standard of questions you can expect in the examination. It will be a kind of okay, a practice for you before writing the actual gate examination. So, so I will the questions which I take up now, I will give some time to you. Okay, just I will give you a bit of a little bit of time, and in that time try to solve that questions and see, okay, whether you able to solve those questions or not. So I hope you can attempt those questions very easily, because to what level you studied in the regular classroom and in the online classes of Medici. So to what level you studied. Okay, so with that, definitely, I'm expecting that you can easily solve this question. I'm expecting so. So let's see. So how many of you will give the answers for these questions? And I want to see to what level you prepared. Okay. So let's check that. See that. So let me take up the first question. I hope you can see this. So let me read it for you. This is related to random variables. And given w equals to ax plus 3y square. Okay. So read carefully. Don't be hurry in examination also. Don't be hurry. So be calm yourself and try to understand each of the line, okay, of the question. Taken. So w equals ax plus 3y square, where x and y are zero mean random variables. Okay. So here a random variable w is defined, and x and y here are zero mean random variables, with variances of x and y are 4 and respect. Correlation coefficient of x and y is -1. Correlation coefficient. A value that minimizes the mean value of omega is how much? We need to find out. It is a numerical answer type question. Fill in the blanks question. It's pretty straightforward question. It's about finding the mean of a random variable. To understand this correlation coefficient, x and y is -5. Yeah, Ashish Kumar, good afternoon. Ashish, is this question is familiar to you? Can you? Okay. What is the answer you got? Anyone? Kumar is saying 8. Devesh Pandey is also 8. Okay. Fine. Let me solve this question for you. Can I? 8 is not correct answer, Devish Pandey. I think 8 is not correct answer. Ashish, 8 is not correct answer. Both are giving the same answer, 8. Oh, this is not correct answer. Yes, let me solve this. If you see W equals to AX plus 3Y square, if you square it, A plus B square, A square plus B square plus 2AB, so it is A square X square plus 9Y square plus 2AB, that is 6AXY. It is a random variable W. This question is about finding the mean value of W, expectation of W. We find this. I am denoting with MW, the mean expectation, also called as mean. MW equals to, if you apply expectation, the expectation of you can apply expectation to individual terms को आप apply कर सकते हैं. Then A square expectation of X square. A square is just some constant. You can write this outside to the expectation. You can write plus 9 expectation of Y square plus 6A expectation of XY. Taking this as equation 1. Okay. Now let's check the given data. Here X and Y having the 0 mean random variables with variances 4 and 16 respectively. So here expectation of X and expectation of Y is equals to 0, both having the same 0 mean, and variance of X and Y are 4 and 16 respectively. Sigma X square is 4 and sigma Y square is 16. Okay, but here we need expectation of X square and expectation of Y square we need. And it is mean square value of X and mean square value of Y. Yes, we know that if mean is 0, then mean square value will be equals to variance only. If the mean is 0, MSQ, mean square value equals variance. So then mean square value of X, that is expectation of X square, equals variance of X only. What is the variance of X here? 4. And what is the mean square value of Y? That will be equals to variance of Y only, that is 16. Okay, fine. Now expectation of XY. Okay, is expectation of XY is given in the question? Is the value of expectation of X given in the question? Yes, given, but indirectly. Your correlation coefficient of X and Y is given as minus 0.5. The correlation coefficient is, you can write as rho xy. This is, it is covariance of xy upon sigma x into sigma y. There is a correlation coefficient of xy, and this will be, is a formula to find the correlation coefficient between two random variables. Okay, so what is the amount of correlation between amount of similarity between two random variables? We can better find out with the help of this parameter, that is correlation coefficient. Okay. Now this is given how much here? Minus 0.5 is given. Covariance of xy, it is expectation of xy minus expectation of x into expectation of y. The regular classroom are given these formulas. Expectation of xy minus expectation of x into expectation of y. And sigma x into sigma y. Sigma x is what here? 2 here. Sigma x square is 4. You know? Sigma x is 2. Sigma y will be 4. And expectation of x and expectation of y, it is given 0 is given. X and y having 0 mean. Okay. So from this, expectation of x, y is equals to, it is 8 times 2 minus 0.5. This is minus 4. It will be equals. Okay. Yes. So we got expectation of x squared. It is expectation of y squared and expectation of xy also we got. Substitute now. Then substitute in equation 1. Equation 1. Yes. Mean of omega, that is equals to a square. Expectation of x squared, this is 4 plus 9 times 2. Expectation of y square is 3 plus 6a times 2. Expectation of xy is minus 4. This is equal to 4a square. 144 this is minus 24a. This is the mean of omega. तो हम क्या फाइंड करना है कि the value of a which minimizes this mean value of omega we have to find out. So to find that a value which minimizes this mean of omega, so do differentiation of this mean of omega, do differentiation of this with respect to a and make it to 0. Okay. Yes, if you do differentiation of this is 8a, differentiation of this will be 0, minus 24 equals 0. Then a will be equals to 3. Okay. And if you want, you can check that if you see the double differentiation of this with respect to a and see the value of that at a equals to 3, then you will come to know that is greater than 0 only you will get. Double differentiation, you're getting greater than 0 means at this a value of 3, this mean of omega yes will give you the minimum possible value. Okay. So what is the value of a for which minimum value of mean we expect is 3? Answer will be 3 here. The a value that minimizes the mean value of omega, that will be 3. 3 will be the answer. Ashish and Devish Pandey, where the mistake you done? हाँ किया आपने mistake. ठीक है. Let's see the next question. Any doubts in this question? Is this question is clear to you, everyone? Just give in the chat box. Give reply in the chat box. Is it an easy question or tough question for you? Just I want to know. Give reply in the chat box. Fine. Let's check the next question. So this is also related to random variables only. Let me read the question for you. Okay, you haven't done differentiation. John Abraham, clear, sir. Okay, fine. Now, the PDF probability density function of a random variable x is fx of x. k, where x is in the interval a to b, 0 otherwise, where k is constant. And a value and b value also given. A is -1. Then what is the probability of mod x less than or equals to c? Okay, for c equals to 1 by 2. Directly, you need to find probability of mod x less than or equals to c is what here? You need to find probability of mod x less than or equals to 1 by 2. Find करना है. It is MCQ type question. 4 options. Which option? And mod x less than or equals to, you can write like this. The probability of x in between -1 by 2 and 1 by 2. What is the probability of x in between -1 by 2 and 1? We need to try to give an answer to the question. This is a simple question only, but in the examination you have to handle the pressure. Okay, so those who handle that pressure, they can easily solve these questions. Even here a and b values, even now you can substitute that. A value is minus, b value how much given is? Ashish, Devesh Pandey, John Abraham. What is the answer? Ashish Kumar is saying C is the option. So only Ashish is there, no others. Others don't want to give the answer. Devesh Pandey is also saying. Yes, C is the correct answer. Good. So So this is some technical glitch, guys. So we are back. So let's continue. The previous question, that was 1 by 3 is the answer. Yeah. This is straightforward question. The answer is 1 by 3. Let's see the next question. This is related to super heterodyne receiver. This is easy one. Let me read this question for you. AM super heterodyne receiver is tuned to 1200 kilohertz station and intermediate frequency is 450 kilohertz. If the lower side injection used for the mixer, then the local oscillator frequency of the mixer and the image frequency respectively will be how much? This is the question. So this is related to super heterodyne receivers. Yes. I just want to see how you handle the pressure in the examination in solving such easy question. I just want to see that. A lower side injection is used for the mixer. It makes all the difference. Yes, in the regular classroom, I clearly mention it. What is lower side injection for the mixer and higher side injection for the mixer? Yes. What is the given data? Let me write this first. Yes. So receiver is tuned to 1200 kilowatt station. So this is Fs I'm denoting with. The carrier frequency of the selected station, tuned station, I'm denoting with Fs. And the intermediate frequency is 450 IF. The lower side injection is used for the mixer. What it means is, you take the mixer, here you can see local oscillator. That local LO I'm denoting with. That local oscillator frequency is FL. The carrier frequency of the selected station is Fs. The tuned station, yes, you can see at the input of the mixer. Now, what local oscillator frequency should be? So, in selecting the local oscillator frequency, two options we have. Or the two options, you can maintain FL value greater than Fs, or you can maintain FL value less than Fs, you can maintain. So, lower side injection, what it means is this FL value is less than Fs. What it means? Higher side injection का ये मतलब है कि FL greater than Fs. Lower side injection means FL is less than Fs. And the mixer, yes, is always designed to perform down conversion only. The difference of frequencies you will see in the output. Difference of frequencies output. Yet Fs greater than FL, no? Fs greater than FL means Fs minus F. The difference of frequencies, that to positive frequency you can see at mixer output. Okay? Fs greater than FL means Fs minus FL. The carrier frequency of the selected station is changed to Fs minus FL. New frequency is only IF is equals to, ठीक है. हम क्या फाइंड करना है कि your local oscillator frequency, yes, we need to find, that is FL you need to find out. FL is equals to Fs minus, so Fs minus IF is, Fs is how much here? This is 1200 kilo minus 450 kilo. So this is 750 kilohertz. Local oscillator frequency. And image frequency. Image frequency is Fs minus 2IF. If FL greater than Fs, if FL is greater than Fs, then image frequency will be Fs plus 2IF. If FL less than Fs, In the case of lower side injection, the image frequency is fs minus 2if. fs, so this is 1200 kilo minus 2if. 2if means 2 times to 450, that is 900. This is 300 kilo. Which option is correct? Is option A will be correct. Yes, Devesh Pandey, Ashish Kumar, correct answer. Option A will be correct. Yes. Is it clear now? Let's see the next question. This is related to linear block codes. Reactive, everyone, reactive, I'm expecting. Let me read this question for you. A systematic 7,4 LBC linear block code has the parity matrix given as also this. Parity matrix denoted as P here. If 00111110 is a valid code word, okay, is a valid code word for given LBC, then A and B values respectively will be. Okay. How to solve this question? If I have to give the hint, I can. I have to give any hint to you? Is for a valid code word C into H transpose equals to 0. This is very useful result, okay, in solving questions. For a valid code word C, C into H transpose yes will be equals to 0, 0 matrix. Kumar, you are saying B is the answer? What about others? John Abraham, Arvind, Aket, Devesh. Yes. So from the given data, first I will try to write the G matrix. Is equals to I, K, this is P transpose. Systematic LBC, then what is the default? You can understand systematic LBC is the resultant code word, the code words which are going to be generated in the resultant code words. Message bits will be in the first k positions and parity bits will be in the last n minus k position. The systematic LBC का ये मतलब है कि message bits will be in the first k position. That is what you need to understand. Then G will be IKP transpose. But one catch point here, what that is? IK. It is compare with n comma k से compare कीजिए. So n is equals to 7 here and k will be equals to 4. It is I4, this is k is 4. And what about the P matrix? What is the order of the P matrix? How many rows here? 4. Okay. And how many columns here? 4 cross 3. P transpose, P is 4 cross 3, then P transpose will be 3 cross 4. 3 cross 4. To write matrices side by side लिखने के लिए, okay, number of rows in it and number of rows in it equal होना चाहिए. Rows तो equal होना चाहिए. Columns can be different, but rows तो equal होना चाहिए. इसमें कितना rows के? How many rows in it? 4. How many rows in it? 3. The rows in these two matrices are not matching. Okay, then IK, the valid pattern for G is not IKP transpose. Not going to be. Even in the regular classroom, I mentioned it. Depending upon the notations used, Okay, G can be IKP transpose or G can be IKP also. Okay, in some textbooks you will see G as IKP depending upon the notations. Means the regular classroom I said it. If you see the expressions for the parity bits, okay, the parity bits we derived from the message bits only basically. इसके लिए कुछ expressions होगा how to get the parity bits from the message bits. Okay, and from those expressions only, the expressions, okay, which are used to get the parity bits, from that expressions only we get the P matrix, parity matrix. And that coefficient of, in that expressions, the coefficients of the message bits, in those expressions, the coefficients of message bits, in some textbooks they will denote with P, in some textbooks they denote with P transpose. If the coefficients of the data bits, message bits, if it are denoted as P, denoted with P, then G will be IKP transpose. And if that coefficients of data bits denoted as P transpose, then G will be IKP hoga, will be IKP. Okay. So then, so depending upon the notations used, that can be IKP or IKP transpose. So this pattern IKP transpose is not a valid pattern here because the rows are not matching. Then what will be the valid pattern you need to understand is the valid pattern should be IKP is the valid pattern. Valid pattern. And let me give one suggestion to you. Generally, in such questions, P matrix, they don't give a square matrix. They don't give a square matrix. The square matrix hai to definitely some ambiguity will be there. Like if it is 4 cross 4 hai to P matrix is 4 cross 4, then some kind of ambiguity will be there. IKP or IKP transpose, some ambiguity will be there. Okay, but in most of the textbooks, okay, if at all, if at all it is square matrix, my suggestion is take G is IKP only. If at all that is square matrix, P matrix, if at all square matrix, the default, okay, take as IKP because it is the pattern what they are using in most of the standard text. Okay, yeah. But if the P matrix is not a square matrix, like this, then do check is IKP transpose is valid pattern or IKP is the valid pattern. Do check that. Okay, yeah. Now then I need H matrix. H matrix will be, what is the H matrix here? So from G matrix you can easily get H matrix. The second part, now here it is, let me check the orders also once. K is equals to what here? 4, and P will be equals to what here? P is 4 cross 3, and rows in it and rows in it are matching, so this is a valid pattern for G. You can expect IKP. Then what will be G matrix क्या होगा? इसमें second part में P है तो इसमें first part में P transpose होगा. इसमें first part में IK है identity matrix, and in H you will see second part is the identity matrix. That to I M means N minus K. Okay, but I need H transpose matrix. What we need? Yes, no. If you see H transpose, if you see the transpose to this, if you want, you can write first H matrix. You can write, then you can do the transpose. Okay. Otherwise, even you can write like this. If you do the transpose to this, then you will get in this pattern. PIM. This is the pattern you can. M is equals to N minus K. N minus K means 7 minus 4. This is I3. Then what will be this H transpose matrix? P to already given hai. This is 1 1 1 1 1 0 1 A 0 1 B, and I3 is 1 0 0 0 1 0 0 0 1. So it is H transpose matrix. Okay. Then for a valid code word C to H transpose will be 0. Into H transpose. What is the code word given 0 0? 4 ones, and I hope so. Yeah, 0 0, 4 ones and 0. C into H transpose will be 0 matrix. Row matrix, all zeros will be there. So you can write H transpose matrix here, and you can do that matrix multiplication, the binary matrix multiplication you can do, but no need to write all those steps. I given a shortcut in the classroom how to do that binary matrix multiplication. What is the shortcut I given is, in this matrix 1 is in which position? Third, fourth, fifth position. Okay. Then if you multiply this with H transpose, the resultant simply will be equals to the resultant simply will be equals to sum of third, fourth, fifth and sixth rows of H transpose. Sum of third, fourth, fifth and sixth rows of H transpose. Okay. The resultant will be equals to, and it will be, it is, you can see 1 plus 0, 1 plus 0 plus 1 plus 0. Okay. This is XOR addition, this is binary matrix multiplication. Addition will be XOR addition. 1 plus 1 will be what here? Oh, it is. Next, A plus 1 plus 0 plus 1. 1 plus 1, 0 is A. A plus 0 to A only. And here B plus 1 plus 0 plus 0. It is B plus 1 only. That is XOR addition only. And it should be equal 0 matrix. 0 matrix means all zeros. Okay. Then from comparison on both sides, A will be 0 and B plus 1 is 0. B plus 1 is 0. Then B will be equals to 1. So A 0 and B 1. So which option is correct? Is option B will be correct. Yeah, Sunidhi Singh, correct answer. A 0, B 1. So here the only catch point here is, in the regular classroom may, okay, generally what is the notations we followed in the regular classroom is, yes, if the expressions for the parity bits like this, if the first parity bit suppose C4 hai, to these are suppose parity bits C4, C5, C6. This is P11 D1 plus P12 D, like this. Then P21 D1 plus 2D2 expressions like this. So this parity bits will be derived from the message bits only, the data bits only. The regular classroom may, this coefficients of data bits we denoted with this coefficients of data bits, we denoted with P matrix. Then G matrix will be IKP. These are the notations we followed. Okay, but it is not a standard pattern, I said, and I mentioned this. If this coefficients of data bits P transpose hai to suppose, then G will be IKP hoga, matrix will be IKP. Okay, so here if P matrix is not a square matrix, like 4 by 3, like 3 by 4, something like that, okay, is not a square matrix, then which is IKP transpose is a valid pattern or IKP is the valid pattern, आप easily check कर सकते हैं and you can proceed accordingly. You can proceed accordingly. Here IKP is giving the valid pattern. Okay, the number of rows in it, equal होना चाहिए. If P matrix suppose is square matrix है तो, like suppose it is 4 cross 4 है तो, like this, then definitely ambiguity will be there in such model of questions. IKP lena hai, IKP transpose lena hai, some ambiguity will be there. But my suggestion is, most of the standard textbooks, they're following this, okay, pattern IKP. If P is square matrix hai to, P is square matrix, then in getting G matrix, go for this pattern IKP, default of. It is my suggestion. Okay. We'll go to the next question. Okay. Everyone do check that question. Yes, let me read it for you. It is related to random processes. WSS random processes XT and YT. So it was clearly mentioned XT and YT are WSS random processes, wide sense stationary random processes. Define a process W of t. These two random processes defining a new process W of t like this. The W of t equals to xt cos omega naught t plus yt, where omega naught is the real positive constant. Fine. For W of t to be a WSS random process, which of the following conditions slash are to be satisfied? In the questions, if you see a phrase like this, is slash r, you can understand that as MSQ type question, multiple select type question. One or more options can be correct. Okay. Yes. Yeah, Sunidhi Singh. Good to know that. Ashish, you're asking some one shortcut for check error of not and code all code have. Oh, Ashish, I'm not getting what you're trying to say. Your question is not clear. Ashish. Try to phrase it properly, your question. What happened, Jitesh? Oh, online ki dunya. Okay. Medici will take the decisions very timely. Jitesh? Of course, now Medici having very strong, have very strong footsteps in online now. The recent ESC most almost equal results we got from online also, along with offline. Students are very much having trust in online also for medicine. You see the recent ESC results, you will come to know that. Yeah. Go through the topper stock in medicine, those who got ranks in ESC, those who selected in ESC. Most of the students took the mains batch online only, even regular class also from online only. Yeah, okay. Jitesh, do try this question. Yes, Ashish is saying A and C. Wow. A and C. Any other answers? Okay, let's do this. For a random process to be WSS random process, two conditions has to be set. What are the two conditions? Mean and ACF, mean and autocorrelation function should be independent of time, should be independent of t. Okay. So first let me check the okay. So expectation of W of t. This will be is if you apply expectation on both sides. So omega naught is constant here. Here x of t and y of t only random processes. In applying expectation, except this random processes, all other quantities you can write outside to the expectation you can write. Because we find the mean at a specific time instant, we find at a specific time instant. At the given time instant pay, this cos omega naught t and sin omega naught t will be constants at the given time instant. And that constants, though, you can write outside to the expectation when applying expectation. Yes, you can write outside. So it will be cos expectation of xt. This is cos omega naught t plus expectation of y t sin omega naught t. Okay. Okay. Yes. Now here the mean should be constant. To get this mean to be constant, expectation of w of t to be constant, the only option here is, even if you take expectation of xt from the given options, say from the given options. So I can say expectation of xt and expectation of yt should be 0. Even if you take expectation of xt, expectation of yt, some constants like some k and k, then the expectation of w of t is still, that is function of time, function of t here. Then it is not going to be WSS random process. So for W of t to be WSS random process, the only condition to be satisfied, the only one condition that need to be satisfied is expectation of x of t, expectation of y of t should be 0 होना चाहिए. Then the mean of W of t will be constant. So option. Now if you see the ACF now, autocorrelation function. So if you see ACF of W of t, this is, I can write expectation of W of t1 into W of t2, you can. This expectation of product will give you correlation. There is an autocorrelation of W of t with the time difference t2 minus t1. The time difference t2 minus t1. Or you can use this formula also, that is expectation of W of t into W of t plus tau. Finding correlation at the time instant t1, t2 or at the time instant t and t plus tau. Notations तो आपकी choice है. So here t1 you can understand, t2 you can understand t plus tau. So this ACF, I can say, in other words, I can say should be function of t2 minus t1 only. ACF should be function of time difference only. t2 minus t1 in terms of t and tau will be what here? Tau. Okay. ACF should be function of time difference only. If at all it is, if you get t1 plus t2 term, t1 plus t2 will be what here? 2t plus tau. If ACF का final result में, if you see the term t1 plus t2, indirectly इसका ये मतलब है कि ACF is function of time, then it is not going to be WSS random process. So ACF का final result में, I'm expecting the term t2 minus t1 only, not t1 plus t2. That is one thing you need to keep in mind. Okay, ठीक है. Now substitute now. W of t1 in W of t2. Yes, it will be. It will be expectation. W of t1, that is x of t1 cos omega naught t1 plus y of t1 sin omega naught t1. This is WT1 into W of t2. W of t2 is x t2 cos omega naught t2 plus yt2 sine omega naught t2. This is okay. Now do multiplication and apply expectation to each term. Let me continue here. Do multiplication and apply expectation to each term. This is now it is if you see these two terms, I'm multiplying this with, then except xt and yt terms, all the remaining terms you can write outside to the expectation. You can write this expectation of xt1 into xt2, expectation of xt1 xt, that is Rx. It is expectation of xt1 xt2 means it is the autocorrelation function of xt only with the time difference t2 minus t2. It is Rx of t2 minus t1. t2 minus t1 in terms of t and tau, you can write Rx of tau. I'm writing in terms of t and tau. Or you can write Rx of t2 minus t1 also, your wish. Okay. Cos omega naught t1 into cos omega naught t2. You can write this outside to the expectation. That is cos omega naught t1 and cos omega naught t2. Okay. Plus. And if you multiply these two terms, this term multiply with this, then it is expectation of xt1 yt2. The expectation of product is correlation, but this is cross correlation between two different random processes. That is cross correlation. There is a cross correlation of xt and yt with the time difference t2 minus rxy, rxy, time difference of t2 minus t1, t2 minus t tau, rxy of tau, cos omega naught t1 sin omega naught t2, cos omega naught sin omega naught t plus. Now if you multiply these two terms now, this term with it is, if you say expectation of xt to yt1, expectation of xt2, this is, if you see expectation of xt to yt1, it is also autocorrelation between xt and yt with the time difference of t1 minus t. I want to write in terms of rxy only. It is in options rxy is given. I want to write in terms of rxy only. Okay. So this will be equals to xt to yt1. This will be equals to, you can write cross correlation of xt and yt with the time difference t1 minus t2. t1 minus t2 is minus tau. So it is, you can write rxy of minus tau, you can write r. If you write this is yt1 xt2, yt1 x, it is a cross correlation between yt and xt with the time difference t2 minus t1. It is ryx, cross correlation between yt and xt with the time difference t2 minus t1, that is tau, ryx tau also you can write. Yes, this is given this as a formula also. Ryx tau is rxy of minus tau, or rxy tau is ryx of minus tau, you can write. Okay, so you can write this is rxy minus tau or ryx tau. You can, I'm writing in terms of rxy. It is rx of minus tau. This is sin omega naught t1 cos omega naught t2. Good. Sin omega naught t1 and cos omega naught t2. So finally, if you multiply these two terms, there is expectation of yt1 yt2, that is ry of t2 minus t1, that is ry of tau, you can write sin omega naught t1 sin omega naught, sin omega naught t1, sin omega naught. Okay. Now this cross correlation, what you see, it also should be independent of time, independent of t. Or I can say, in other words, ACF should be function of time difference only. Okay. It should be function of t2 minus t1 or t1 minus t2, function of time difference only. That is a requirement. Then I can say this random process W of t will be WSS random process. Now is the Rx tau and Ry tau. Okay. So if you see the options may Rx tau is relating with Ry tau and Rxy of minus tau relating with Rxy tau relating with t. If you see these two terms, suppose if Rx tau equals to Ry tau hai to, suppose Rx tau equals to Ry tau, then it is cos A cos B plus sin A, is cos A cos B plus sin A, is cos A minus B hoga. Cos A minus B means t2 minus t1 term. Okay, the condition to be satisfied. Another one is if you see these two terms from the given options, if you see what is the option is given, Rxy minus tau is minus Rxy tau. So this is Rxy minus tau. This is Rxy minus tau. Suppose it is equals to minus Rxy tau hai to, it is, suppose it is minus Rxy tau hai to. If at all this is same as Rxy tau hai to, suppose Rxy minus tau is same as Rxy tau hai to, suppose not minus Rxy tau, it is Rxy tau. And if you take this common, it is you can say sin A cos B, sin A cos B plus cos A sin B, sin A plus B hoga. Sin A plus B means that is t1 plus t2 term you will get, and that is not becoming WSS random process. If at all Rxy minus tau is minus Rxy tau hai to, minus Rxy tau hai to, then if you take this minus Rxy tau common, minus Rxy tau if you take common, is sin A cos B minus cos A sin A minus B. Sin A minus B means you will get the t1 minus t2 or t1 minus t2 term you will get. Okay, or sin A cos B minus cos A sin B, that is sin A minus B, you will get t1 minus t2 or t2 minus t term you will get. So here if this condition also has to satisfy, so this Ry tau, suppose it is same as Rx tau and Rxy minus tau is minus Rxy tau hai to, better. Then what is the ACF of W of t? So if you take this Rx tau common, Rx tau is sin A sin B plus cos A cos B plus sin A sin, that is cos A minus B, that is cos A minus B means cos omega naught t2 minus t. Okay, plus we take Rxy tau common from this. For Rxy tau, if you take common, it you can say sin A cos B minus, it is sin A cos, it is I'm taking it is sin A cos B minus cos A sin B, that is sin A minus B sin omega naught t2 minus t. The t2 minus t1 so you can write as tau, you can write time difference tau, you can write place of t2. Okay, now you can see ACF is function of time difference only आप check कर सकते हैं. If you take Rxy tau common from this, this is sin A cos B minus cos A sin B, that is sin A minus sin A minus. The ACF is function of time difference only, function of tau only. You can no t terms, so it is WSS random process. So here A, B, C has to be satisfied. D is not correct. If Rx tau is minus Ry tau hai to, if you see Rx tau is minus Ry tau hai to, it is minus Ry tau hai to, okay, then what you will get here is if you take that common cos A cos B minus sin A sin B term, you will get cos A cos B minus sin A sin B, that is cos A plus B. You will get T1 plus T2, you will get T1 plus T2 means that is function of time, so that is not WSS random process. A, B, C has to be satisfied. या जान अब्राहम ABC, आशीष ABD नहीं ABC है ना, ABC. Ashish, is it clear to you? You've given the answer ABD, but this is ABC. ABD नहीं ABC है ना, Rx2 should be equals to R2. See, this R2 is Rx2. Then if you take this common, then cos A cos B plus sin A sin B, then you will get cos A minus cos A minus. You will get time difference only, function of time difference. Yeah, let's proceed to the next question. You like this question? This is a good question, huh? Yes. Okay. Let me read this question to you. This is related to delta modulation. Message signal having maximum frequency of 6. Maximum of 6. Given to delta modulation system. That is maximum frequency. Simply you can denote with FM also, the maximum frequency signal. FM, F max is given to delta modulation. Sampling rate is 2.5 times to Nyquist. Assuming no SOE, no slope overload error, maximum signal to quantization noise ratio of the dash. Okay. Addition नहीं होना चाहिए. Okay. T1 plus, if ACF is function of T1 plus T2 है तो that is indirectly function of T होगा. Function of T means that is not a WSS random process. Then हम उसको WSS random process नहीं बोल सकते हैं. Or you can use the formula otherwise, W of T into W of T plus tau. W of T plus tau. Okay. You can use that formula also. By using that formula also you can proceed. You can solve this. You can find this ACF. Okay. Then definitely the final result में T1 plus T2 terms नहीं मिलना चाहिए. T1 plus T2 term मिल गया है तो indirectly it is function of T, function of time. ACF is function. Then it is not said to be WSS random process. To be called as WSS random process, okay, ACF should be function of time difference only. Function of T1 plus T2 कभी भी नहीं होना चाहिए. Then वो WSS या ट्रिपलेस रैंडम प्रोसेस, एरगैडिक रैंडम प्रोसेस नहीं होगा. Will not be. Normal random process होगा in that case. That will become a normal random process. ठीक है. So I given a formula for it, the regular classroom. I have not derived that formula. Derivation to I have not given. I given that formula directly. I told you to remember that formula. Okay. So for the condition of no SOE, the maximum S by NQ. NQ, it is nothing but quantization noise for, I mean. Maximum output SQNR. O means output. Maximum output SQN. It is 3 Fs cube upon 8 pi square Fm square Fc. I given this formula directly in the regular classroom. Okay. Fs is the sampling rate and Fm is the message frequency. Yet Fc is the cutoff frequency of the low pass filter. Because in the last stage of the DM receiver, a low pass filter will be there that works as a reconstruction filter. So this Fc is the cutoff frequency of the low pass filter. If Fc दिया है the question में cutoff frequency of low pass filter given, you can directly substitute. If not given, then default, if Fc not given, default Fc is equals to Fm, because that low pass filter is designed to allow only message signal, then cutoff frequency of low pass filter is equals to Fm only, default of. Then it will be Fc you can replace with Fm, Fm square into Fm, Fm cube hoga. So this is 3 upon 8 pi square, Fs cube upon Fm cube. So Fs upon Fm cube you can write. It will be. I said that this formula I will take up in conventional batch, ESC mains batch में I will take up this derivation. I said for objective examination के लिए I told कि just remember this. Okay. After ESC prelims, after ESC prelims you can join conventional practice program mains batch. There I will take up such derivations, some critical questions, big derivations which are required only for the mains examination. So those topics will be taken in the mains batch. Now if you substitute here, this is a sampling rate. If you sampling rate is 2.5 times to Nyquist. So if F equals to 2.5 times to Nyquist, the Nyquist rate here is 2.5 times to Nyquist. Nyquist rate is 2 Fm, 2 times to maximum frequency. That maximum frequency I'm denoting with Fm. So this will be equals to 5 Fm. Fs equals to okay. Now if you substitute S by NQ is equals to 3 upon 8 pi square. Okay. Fs is equals to 5 Fm upon Fm cube. This is okay. It is 5 cube, that is 123 times 125 upon 8 pi square. Try with calci. Keep the calculator in radians mode, okay, and do this. Then you will come to know this is 4.74 you will get. Most of you given the option B is the correct answer. That is actually the mistake, John and Kavali. Because if you see, he's expecting S by NQ in decibels. You have to take care of this. If it is not mentioned in decibels, then 4.74 will be the answer. But it is given in decibels now. So to get S by NQ in dB, okay, it is a power ratio, signal power to quantization noise power ratio. Power ratio in dB means is 10 log. This is 10 log 4.74 karna hai. You will get in decibels. What is 10 log 4.74? that will be 6.7 6.76 GB. So option A will be correct. So that's why you should be very careful about the units. Which you are expecting answer, you should be very careful about that. Okay. So remember this formula for objective examination. Let's see the next question. This is for gate examination. Okay? Giving these questions for gate. In ESC prelims, so we don't expect such questions generally. Okay, because calci is not available to you ESC prelims, but gate mein to calci is available. In gate, you can expect this question. These questions, this session which I am taking for gate examination. Session name itself GTQ, no? Gate through questions. Okay. So it is a general question. This is. So here a system is given, V1T is given to nonlinear system and given to band pass filter V3T. Here the expression for V1T is given. 10 cos 2000 pi t plus 4 200 pi t. Applied to following system. V2T and V1T relation of V1T pi t. And the band pass filter is ideal unity gain filter, okay, with pass band from 800 to 1200. See the band pass filter. The pass band from 800 to 1200. The band pass filter is allowing only from 800 to 2 pass band. Then the expression for V3 what? I can't say not useful. Okay? I can't say it's not useful for ESC prelims. Because in ESC prelims, you can expect theory questions also, not only numerical questions, you can expect theory questions also. You can. Gate mainly, you can expect the numerical questions. I can't say it is not useful. But some questions where calci is required, such questions generally we don't expect in ESC prelims. This question though you can expect in ESC prelims also, can be, because here calci is not required to solve this question. Can you do this question? I'm expecting answer. Try this, everyone. Yes, so Devesh is saying A and Sunidhi is saying D. So let's check which is the correct answer. Meanwhile, you can others also try to give the answers. So here V2T is equals to this V1T plus 0.1 V1 squared. Yes, V2T is equals to V1T plus 0.1 V1 squared. Okay. Now if you substitute V1T, if you substitute, what is V1T? It is 10 cos 2000 pi t plus 4 sine 200 pi t plus 0.1 V1 squared. If you square it, A plus B square, A square plus B square plus 2AB. So A square means is 100. This is cos square 2000 pi t, B square, that is 60, sine square 200 pi t plus 2AB. 2AB means that is 8. Okay, 2AB. 40 to the 8, 80. This is cos 2000 pi t and sine 200 pi t. Now this is given to band pass filter. What is the output of the band pass filter? That is V3T. So let's try to get the expression for V3T. Now we have to check which of these terms allowed by the filter and which terms are not allowed. The filter is allowing only from 800 to 1200. What is the frequency of this? It is 1000 Hz. So this term to allowed here. 1000 Hz is within the passband of the filter and this term will be allowed. What is the frequency of this term? That is 100 Hz. It is outside to the passband of the filter. It is not allowed. Now cos square 200 pi t. Cos square theta, you can write 1 plus cos 2 theta by 2 is 1 plus cos 4000 pi t by 2. The first term is the DC term, that is not allowed by the band pass filter. DC का frequency क्या है? 0 Hz. That is not allowed by the band pass filter. DC term is not allowed. The frequency is 2000 Hz. 2000 Hz is also outside to the pass band. That is not allowed. So altogether, this term is not allowed. And even if you see this term, sine squared theta, 1 minus cos 2 theta by 2. So 1 minus cos 400 pi t by 2. This DC term to not allowed. Okay. DC term is not allowed. And what is the frequency of this? Will be 200 Hz. Is also outside to the passband. That is not allowed. Altogether, this term is not allowed. What about this last term? So first, let's check which frequency is present in this last term. To check that, do simple expansion: sin A cos B, sin A plus B plus sin A minus B by 2. So sin A plus B. Sin A plus B means 2200 pi t plus sin A minus B, sin A cos B, sin A plus B plus sin A minus B. Sin A minus B means sin minus 1800 pi t, or you can write minus sin, this is 1800 pi t upon 2. This is sin A cos B, sin A plus B plus sin A minus B. Sin A minus B means sin minus 1800 pi t, that is minus sin 1800 pi t by 2. What is the frequency? Which frequency is 100? Both are within the passband of the filter only, so allowed by the filter. So this last term, yes, will be allowed. Okay, but all the options are given. Okay, expansion के बाद इसको expansion करने के बाद क्या terms मिल रहा है? वो expansion terms में options दिया है. So then what will be the answer here is, so this term is allowed. This is 10 cos 2000 pi t. So it is, you can see 80 upon 2. The 80 is then, this is expansion of only this, is the expansion here. 80 upon 2 is 40, and 40 times 2.1, 40 times 2.1 is 4, is plus 4 sine 2200 pi t minus 4 sine 1800 pi t. So which option is correct here? Which option is correct is option D will be correct. Yes, Sunidhi Singh, Ashish, Anshuman, correct answers. Good. Yeah, is it is okay now? Is it still buffering or it's fine now? I think it's clear now. Yes. Now. So here the peak amplitude of the carrier signal. What is the carrier signal? Sinusoidal carrier? AC cos 2π. What is the peak amplitude of the carrier? The AC you need to find out. AC value you need. If it is specially mentioned that the peak amplitude of the carrier after modulation, if it is mentioned that the peak amplitude of carrier after modulation, then that is indirectly the peak amplitude of the resultant AM signal. The peak amplitude of resultant AM signal, that is Amax. Then you need to find Amax. But question may, it is just you need to find peak amplitude of the carrier signal. AC only you need to understand. Okay, you need to understand. Okay. What is the answer? Which topic to revise priority wise? Anshuman, in the regular classroom also I said it, like digital communication के लिए आप थोड़ा ज़्यादा focus दीजिए. Okay. Now you need to find AC value. Just peak amplitude of the carrier means you need to find AC. If it is specially mentioned that the peak amplitude of the carrier signal after modulation, then in that case Amax you need to find out. But in this question you need to find AC को find करना है. And what is the data given here? AM transmitter radiates the total power of 5 kilowatt. Total power means PT. Okay. The modulation index is given. PT mu given. Then you can find PC, so you can find first. Yes. PT is equal to PC times 1 plus mu square by 2. Okay. PT though it is 5 kilowatt. PC times 2, 1 plus mu. 0.7071 means that is 1 upon root 2 only. Okay. So mu you can write it as 1 upon root 2. So it is mu square means 1 by 2 upon 2. It is 1 by 4. Now this is 5 kilowatt. This PC times 2. 5 will be cancelled. Then PC is equals to 4 kilowatt. Once you got PC, then you can easily find out the carrier amplitude. You can find out. What is the answer you got? I'm expecting answer from you. Anyone? How to find? This is PC is equals to AC square by 2R. Okay. PC is 4 kilowatt. All the options are given in volts में पूछा है, kilovolts में नहीं. All the options are given in volts, so I can write this is 4000 watt. AC square upon 2 into R. The load resistance is given. Load resistance here is nothing but antenna resistance only. That is 50 ohms given. So this is now A is equals to under root of, this is 4000 times to 2 times 50 under root of. Try with calcium. It is 632 now. So this is 632.4 volts. Option B is correct now. Then why most of you given wrong answers? Be careful about calculations, okay? Be very careful about calculation. Kavali, Anshum, Jan Abraham, Devesh Pandey, Ashish, correct answer. Okay. You see the next question. Let's check the next. It is related to angle modulation. An angle modulated signal with carrier frequency omega c 4 pi times to 6 second is given as c is equals to cos 2 is 25 sin 30 plus 50 cos 100. The bandwidth of this of the bandwidth of this angle modulated signal and in hertz. Okay, it's not in kilohertz, it is in hertz. Hi everyone. Bandwidth, angle modulated signal. तो बीटा से आपको पता चलेगा किस फॉर्मूला यूज करना है. फर्स्ट फाइंड आउट द मॉड्यूलेशन इंडेक्स बीटा. द बीटा, based on the beta you can decide this is wideband angle modulated या narrow band. Wideband है तो you have to use Cartson's rule formula you have to use. If that is narrow band है तो then simply 2 FM. The bandwidth will be 2 FM. Just do check first. Is it is narrow band angle modulated signal or wideband angle modulated signal? How to get beta? Beta is simply delta F by FM. Do check, everyone. How to find delta F? How to find delta F? For angle modulated signal के लिए how to find delta F? Given a suggestion, first find instantaneous frequency Fi, and from instantaneous frequency Fi say okay, you will get frequency deviation, then maximum frequency. That is a general procedure to find delta F. What is the answer you got? Anyone? Let's check this. It's angle modulated signal st equals to cos 2 pi times 2 times to 10 power 20 sin 100t plus cos 100t. So you can see this as standard angle modulated signal, where this is the total angle of the angle modulated signal theta I of t cos theta I of t, where theta I of t is the total angle of angle modulated signal, and then it's instantaneous frequency fi, or you can denote with fi of t also. How to find instantaneous frequency from instantaneous angle is 1 upon 2 pi differentiation of theta I of t, then fi is equals to 1 upon 2 pi. Okay. Differentiation of theta I of t. What is the differentiation of this 2 pi? So yes, you can write outside only. Differentiation of this 2 into 10 power 6 plus this is 25 times 200, 2500. Differentiation of sine will be cos 100t. Differentiation of cos is minus sine. 50 times to 100 is minus 5000 sine 100. See, this is 2 pi will get cancelled. Then fi is equals to 2 into 10 power 6 is 2500 cos 100t minus 5000 sin 100t. This is so. This is it is fc only. Omega c is 4 pi into 10 power 6. Then fc will be fc. If you divide with 2 pi, okay, that is 2 into 10 power 6. It is fc only. So when you compare with unmodulated carrier frequency, fc से compare करने पर, this is the frequency deviation I can. This will be frequency deviation. Once you got the instantaneous frequency, from this you can easily find out the frequency deviation. Then what will be the maximum frequency deviation? Maximum frequency deviation delta f will be equal to max of this. That is 2500 cos 100t minus 5000 sin 100. What is the max of this? Is the frequency deviation, maximum frequency deviation is max of this. No importance to importance magnitude. Just need maximum frequency deviation. That can be in positive direction, negative direction, I don't mind. No importance to magnitude. This combination of sine and cos. Okay. And what is the max of this? Is a sine plus b cos, yeah, a sine minus b cos. It can be plus or it can be minus. Okay. A sin plus b cos or a sin minus b. Root over a square plus b square. Maximum 2500 square plus 5000. Do this. How much you are getting? This is 5590. This is hertz. Okay. Then beta is equals to delta f by fm. A message signal having single frequency only. So this is related to the message signal. This part is related to the message signal. Because even if you see this as FM signal or PM signal, this part is related to message signal. As if you see this as PM signal, angle modulated means visualize this as PM, yeah, FM also. If you visualize this as PM signal, what is the general expression of PM? AC cos 2 pi fct plus kPmt, kPm. If you see this as FM signal, then AC cos 2 pi fct plus 2 pi kf integration mt, 2 pi kf integration mt. Even if you see this as PM, yeah, FM, this part is actually related to message. You can see message signal having single frequency. It is sin 100t, it is also cos 100. Same frequency. It is having single frequency, the message signal. So what is that frequency will be? It is delta f is 5590 fm. If you compare with sin 2 pi fmt, cos 2 pi fmt, 2 pi fm is 100, fm is 100 upon 2 pi. Keep the calci in radians. Try this. You will get the beta value. How much you are getting beta value? $15.91 you're getting. 0.91 means beta is greater than 1, it is WBFM only, you can see. Then bandwidth by using Cartesian's wideband only. So you can use this formula beta plus 1 into 2FM or 2 times to delta F plus FM. Any of the formulas you can. 2 into delta F plus or beta plus 1 into. So let me use this formula. 2 times 2. This is delta F. Delta F is 5590 FM. FM is what here? 100 upon 2 pi. How much you are getting? This is try with calci. 11,000 to 11.8. So this is 11,000 to 12 hertz. Which option is correct here? Option A will be correct. 11,000 to 12 hertz. A. Let's check the next question. This is related to PSK. This is. Let me read the question for you. A BPSK signal equiprobable bits transmitted to an AWGN channel received by a correlator receiver. Okay. If the probability of error PE is 0.5, then the phase mismatch between the carrier used in transmitting receiver is okay. Kavali is saying beta is 351. Really? If beta is 351, calci properly. What is 100 upon 2 pi? Fine, this is 100 upon. What is the value of? Tell me that. 100 upon 2 pi. So don't write direct like this. Whenever you are using calci, do like this. 100 divided by 2 pi. Do like this. When you are using calci. 2 pi is 6.28, no? Otherwise, pi is 3.14, 6.28. 100 upon 6.28. How much? 15.92. 5590 upon 15.92. How much? Okay, let me check. Oh, okay. 351. Divided by. Yeah. 100 upon 2 pi I written here 15.91. Yeah, that's correct only. Says yeah, 351. 351 point 100 upon 2 pi only directly I written here 351.2. Yes. Yes, Sunidhi, 350. Yes, surely correct answer. Okay. What about next question? What is the answer? Yes, see in the workbook may I given one question, the regular classroom workbook I given question, similar model of question. Some phase mismatch is there between the carrier used at the transmitter and receiver. Phase mismatch, and how probability error will get affected. So probability error of BPSK, normal PSK is Q of root over 2 EB by N naught into cos. you want to write cos phi inside to the under root, that is cos square phi. If you want to write this outside to the under root, that is cos phi. Okay. And this probability error of BPSK Q of root over 2 EP by N naught. I derived this formula for these conditions. What the conditions? AWGN channel is what I considered, and the equiprobable bits P0 equals P1. I considered AWGN channel. Okay. For those conditions only, I derived this formula. And if there is no phase mismatch between carrier used at the transmitter and receiver, then phi will be 0. Phi is the phase mismatch. How much phase mismatch? Okay. A phase error is there between the carrier used the transmitter and receiver. That is fine. If there is no phase mismatch, phi will be 0, cos 0 will be 1. Of root over 2 e by n naught. It is clearly given the probability error, it is equals to, yes, given PE is given 0.5. Okay. We know that Q0, we know that Q0 will be equals to 0.5. Q of 0 will be 0.5. So it should be equal 0 now. To get this quantity 0, this quantity to get 0, then cos phi should be 0. Okay. Cos phi, if cos phi is 0, okay, then it will become Q0. Q0 means that will be equals to 0.5. Phi should be, cos phi should be 0, then I can say phi should be 90. Cos 90 will be 0 now. So from the given options, this C will be the correct answer. Yes, Devesh Pandey, Ashish, C is the correct answer. Everyone clear with this? The next question, question number 11. This is related to channel capacity theorem. Based on that, read the question here. A binary data is transmitted an ideal AWGN channel with infinite bandwidth. Ideal AWGN channel itself, nothing but the bandwidth is infinite. Channel bandwidth is infinite. Even this infinite bandwidth is not specially mentioned. The ideal AWGN channel इसका ये मतलब है कि channel का bandwidth P times ideal channel. So infinite amount of channel bandwidth is available. The two-sided power spectral density of noise is n naught by 2. Okay. If the average energy transmitted per bit is, then the condition to be satisfied for error-free transmission, condition to be satisfied for error-free transmission in terms of EB upon N naught. I derived this formula actually. What is the answer for this? So in the regular classroom, I derived this formula. What is that? Is for error-free transmission. For error-free transmission के लिए P greater than or equals to RB for error-free transmission, and C is equals to, आपको याद है तो, for AWGN channel B log base 2, this is 1 plus S by N greater than or equals to RB. Okay. And if you write this in terms of EB, if you write S is signal power, power is equals to energy upon time, power equals energy upon time duration T, EB upon TB, or you can write E RB, you can write. The noise power, it is N naught B, where B is the channel bandwidth. You have to use this linked formulas. EB upon TB, energy upon time, or EB RB, noise power. For AWGN channel, what is the noise power over a bandwidth of B hertz? That is not B1. From this, I done this derivation in the regular class. P upon N naught for error-free transmission is 2 power RB by B minus upon this is RB upon B. This is the condition to be satisfied for error-free transmission, where RB upon B, bit rate upon bandwidth, is also called a spectral efficiency or bandwidth efficiency, is also called this. Okay, but here it was mentioned for ideal AWGN channel where bandwidth tends to infinite. If the infinite amount of channel bandwidth is available, by applying that condition, what is the condition? By applying that condition, how this result will get changed? You have to see that. For ideal AWGN channel, then EB upon N, what is EB upon N naught? As B tends to infinite, what should be EB upon N naught? As B tends to infinite, we have, as B tends to infinite, RB by B tends to, then 2 power RB upon B minus 1 by RB upon B, this is. Okay. So one famous result in limits, like limit x tends a power x minus 1 by x will be equals to ln a. Ln means there is e only, the default of ln means that is e. Or you want to write in terms of log में लिखना है तो also log ln a log, but base is what here? Both will be equal only. Both will give you the same result. Ln, it is actually basically equals ln a. You want to write in terms of log में लिखना है is log a, but base e होना चाहिए. Base should be e. So this, from this, EB upon N greater than or equal to. So it is x का प्लेस में RB upon B है, x का प्लेस में, and a का प्लेस में क्या है? Place of a, this is 2. Okay. This is ln 2, but all the options are given in terms of log. I can say log 2, but base e होना चाहिए. The regular classroom, I given this result in dB में I given. So if you find this is in dB में EB upon N naught क्या होना चाहिए? It is 10 log. 10 log of log to base e. Then that is minus 1.59 you will get. If you see 10 log to this, then you will get minus 1.59. Okay. But here options are not given in dB में नहीं दिया है. So log to base e. So which option is correct? Is option A will be correct. This is not correct. Here, this is base nahi diya hai, to the base is 10. You can understand the default base is 10. Base is 10. Default of block ka. Block 2 base E. Option A will be correct. Okay, let's see the next question. The differential entropy of a Gaussian random variable. Okay, differential entropy of a Gaussian random variable with 0 mean and variance 2 will be. It is a standard question. Okay, the regular classroom, I have not given the formula for it. Yeah, ln2. If it is given, it is simply place of this, they can give ln2 also. That is also correct answer. Just ln2. ln2 itself, the base is E here. ln means the base is. In place of this, ln2 also can be given. That is also correct answer. This formula I have not given in the regular classroom, but so in the preparation process, I thought like you might come across this from any other sources. This can be given in 2 marks, can be given for 2 marks, can be given for 1 mark also. Is given for 2 marks means the examiner is expecting that you have to derive it. Is given for 1 mark means provided you remember it as a standard formula. In that case, you can see it as a 1 mark question. Yes, it is differential entropy. What differential entropy is? Entropy of a continuous random variable. Okay, that is basically called as differential entropy. Entropy of a continuous. So hx, where x is a continuous random variable, it is minus integration. What is the entropy of a continuous random variable? Integration. It is fx of x log fx of x base 2 dx. Okay, is the entropy of a continuous random variable. This is. And Gaussian, and here you need to find differential entropy of a Gaussian random variable. For Gaussian random variable is basically continuous random variable only. What is the density function of Gaussian random variable? With mean a, if x is equals to n of a comma sigma square. We take Gaussian random variable. इसका a मतलब है कि x is the Gaussian random variable with mean a and variance sigma square. Means x is having normal density function or Gaussian density function with mean a and variance is sigma square. So what is the density function? 1 upon root to 2 pi sigma square to e power minus x minus a square by 2 sigma square. This is. Now you need to substitute this fx of x. This fx of x you need to substitute. This is a big derivation only. This is. Okay. But the end result will be like this. The end result is hx is equals to half log 2 pi e sigma square base 2. This base 2 you will get half log 2 pi e sigma square. So this entropy of Gaussian random variable result is independent of its mean. Mean पे depend नहीं होगा, not depending upon the mean, not depending upon a value. Half log 2 pi e sigma square. This is, it is, you can remember as a formula. This is the differential entropy, or I can say entropy of a Gaussian random variable whose mean is a and variance is sigma square, is given by this formula, half log 2 pi e sigma square. This is 2 pi e sigma square. And here, what is the given? The question, the mean is given 0. Variance is given how much? Sigma square. The variance is, then entropy H will be Hx, or simply I'm writing will be half log 2 pi e sigma square. Sigma square is 2, no? So 2 times 2 by 4 pi base 2. To match with the given options. To match with the given options, writing this half log AB, you can write log A plus log B, you can writing this match with the given options. Log pi E given, no? Log pi E, so I'm writing log 4 plus log this pi base 2. Okay, log 4 base 2 will be 2 only. Log 4 base 2 square, you can write 4, 2 square, you can write 2, you will 2 upon 2, so 1 this plus is half times 2 log base 2 pi. This is the entropy what we got. Which option is correct here? Is option C will be correct here. Some formulas, so it's better to remember, okay? Because if you don't remember this, derivation of this will take hell lot of time. Substituting fx of x here, doing all this computation calculation, it takes hell lot of time. Some formulas are better to remember, like signal to quantization, noise power ratio of delta modulation. We've done one question already on that. And this is the differential entropy of Gaussian random variable. Let's see the next question. Let me give you the next question. This is related to the random variables. The random variable V and W show me defined as the random variable V and W here, two random W with 0 mean are defined as V equal to X plus W is equal to X minus C. Let's see some real number, and X and Y are of course random variables. Okay. If mx2 and my2 are the mean square value of x and y respective, these are the mean square value of x and y respective to m. Mean square value generally we denote with m2. M2 we can call as mean square value. It is the mean square value of x, it is mean square value of y. Then the value of c is such that v and w are orthogonal. We have to find out. V and w are orthogonal. Try this. What will be the answer? Try to give the answers. Answer for this question. Let me give some clarification. That is, you take two random variables x and y are said to be uncorrelated. Uncorrelated provided covariance of x, y is equal to 0. Covariance is the measure of correlation between two random variables. Covariance 0 है तो no correlation between random variables, said to be uncorrelated. Covariance का फॉर्मूला क्या है? Expectation of x y minus expectation of x in expectation of covariance. Okay, the covariance 0 है तो or expectation of xy is equal to expectation of x into expectation of y. Okay, then you can say x and y are uncorrelated. X and y are said to be orthogonal with reference to random variables. Slight difference will be there between orthogonality and uncorrelation. X and y are said to be orthogonal provided expectation of xy is 0. Expectation of xy 0 है तो okay, then I can say x and y are orthogonal. The difference, be careful about this. Expectation of product 0 है तो then x and y are orthogonal. Then you can say x and y are independent. Two random variables x and y are said to be independent. Okay, provided expectation of xy is expectation of x into expectation of y, but not only for the first order, for every possible order this quality should hold good. Like expectation of x square y square, the expectation of x square into expectation of y square, like that. Or expectation of this x power m into y power m be equal to expectation of x power into expectation of y power n. M and n can be equal or can be different. Like if expectation of x square y cube hai to that should be equals to expectation of x square into expectation of y cube, provided all these conditions are satisfied. All these conditions satisfied, then I can say x and y are independent. Not only for first order, for every possible order satisfy hona, then you can say x and y are independent. So this, be little careful. Now here the value of c is such that v and w are orthogonal. We have to find out. Yes, if v, for v and w to be orthogonal, and say expectation for v times w 0 होना चाहिए. Expectation v times w. You see v times w is x plus cy into x minus c. So a plus b into a minus b, a square minus b square. So it is x square minus c square y square. This is zero. This okay. You can apply expectation to each term separately. You can is expectation of x square c square, so you cannot outside the constant, connect outside to the expectation times to expectation of y square. Expectation of x square means mean square value of x only. What is the mean square value of x given? Denoted as mx2 minus square. Mean square value of y, my2. So from this, p will be equals to root over mx2 upon this is my. Which option is correct here? Root over mx2 upon my2. Option D will be correct now. Here option D will be correct. Option is correct. None of you given correct answer for it. No one given correct answer. My suggestion is better be clear with these things. Okay. This is related to information theory. See how many of you the answer for it. Two independent random variables p, okay, they given both are independent random variables are related to another random variable z, where z is equals to a plus b square. If set of values possible for a is -1, set of values for b is 0 and 1. Here a and b discrete random variables, discrete set of possible values for them. The entropy of z, we need if all the symbols of a and b are equally probable, we need all the symbols of a and b are probable. So what it means, the probability of this a is equals to minus a is equals to probability of A is equals to 1 is 1 by 3. So all the symbols possible for A are equiprobable, that is 1 by 3, and all the symbols possible for B also equiprobable, that is probability of B is equals to 0. B is equals to 1, 1 by 2. Equiprobable means 1 by 2 each. Then we need to find entropy of Z. Here A and B are discrete random variables, so Z is also we expect is discrete random variable only. So to find the entropy of a random variable, we solved such questions already. Ashish, Kavali, Saket Sai, Dan Abraham. Try to give the answer to the question. Devesh Pandey. So we already done such questions. Just the presence of mind is required in the examination. Think positively. Calm and compose. Presence of mind is required. So how to find the entropy of a random variable, entropy of a discrete random variable? Entropy is all about measure of uncertainty. Okay. I'm finding entropy of a discrete random variable. इसका ये मतलब है कि about z value क्या uncertainty है? About z value, what is the uncertainty? What we are trying to estimate. So how to find the entropy of a discrete random variable? How to find the entropy of a discrete random variable? What is the procedure? First you have to see what are the different values possible for random variable. वो आप देखना है. रैंडम वेरिएबल टू टेक दोज डिफरेंट वैल्यूज क्या क्या प्रोबेबिलिटीज हैं एंड उस प्रोबेबिलिटीज को बेस करके हम एंट्रोपी को फाइंड करना है. So to find the entropy, we need the associated probabilities we need. Yes, no? Yes, let's see what are the different values possible for z. Let's see that. That is a plus b square ना. Okay. In doing this computation, a का value क्या होगा? A can be -1, 0 or 1. B also can be 0 or 1. These are the possible values for A and possible values for B. In doing this computation, what are the possibilities here? A and Z here. Z here is A plus B square. If A value, if at all -1 है तो A value -1 है तो B can be 0 or 1. In doing this computation, so many combinations possible. In doing this calculation, so many combinations. One combination is A -1, B A -1, so B can be 0 or 1. When A is 0, A 0 है तो then B will be 0 or 1. B can be 0 or B can be 1. A 0. When A 1 है तो is possible, all possible combinations you have to take up. Okay. Because in doing this calculation, so many combinations of A and B possible, and all those combinations you have to consider. So when A 1, then B will be 0 or 1. And A plus B square. A plus B square means it is 1. Yes, A plus B and square. It is 0 minus 1 plus 1, 0. 0. And this is 1. And this is 1. And 1 plus 1, 2. 2 square means 4. Okay. So what are the different values possible for Z? So the values possible for Z, I'm denoting with Zi, small zi. What are the different values possible for Z? Whenever you are finding entropy of a discrete random variable, should be little careful. What are the different values possible for random variable? Those different values are considered. Only 3 different values possible for it. X is 0, 1, 4. 3 different values possible for it. To take those different values, kya probabilities? That probabilities have to take up. Probabilities. Z value 0 के लिए क्या probability? This is Z value 0 के लिए क्या probability? To get the Z value 0, you can see Z value 0. So this is one possibility. A should be -1, B should be 1. A value minus A should be -1 and B should be 1. And means, so to get Z 0, A should be -1 and B should be 1. Okay. And A and B are independent. It is given. What is the probability of occurrence of 2 independent events simultaneously? Multiple. And means multiplication. Probability of occurrence of 2 independent events simultaneously multiplication. A value -1 के लिए probability 1/3 and B value 1 के लिए 1/2. 1/3 times to 1/2. 1/6 here, 1/6. और this ये एक पॉसिबिलिटी है और एक पॉसिबिलिटी भी है Z0 के लिए और एक पॉसिबिलिटी भी है A0 B0. A0 B0 के लिए क्या प्रोबेबिलिटी है? सेम थिंग 1/3 times to 1/2. 1/6. तो टू गेट द Z वैल्यू 0, ये एक पॉसिबिलिटी है और ये एक पॉसिबिलिटी है. सो ये पॉसिबिलिटी के लिए प्रोबेबिलिटी 1/6 है और मीन्स प्लस. ये पॉसिबिलिटी के लिए प्रोबेबिलिटी क्या है? 1/6 है. इट इज 2/6 और आई कैन से 1/3. दिस इज 1/3. 1 के लिए so many combinations, so many possibilities हैं Z value 1 के लिए. Okay, this combination के लिए 1/6 है. Each of this combination having equal probability. Each of this 1/3 times to 1/2, 1/3 times to 1/2, 1/6. Every of this combination having equal probability 1/6. It is 1/6 plus 1/6 plus 1/6. Z value 1 के लिए a possibility और ये possibility या ये possibility है. R means plus 1/6 plus 1/6 plus 1/6. It is 3/6. So 3/6 means you can write 1/2 you can write. It is 1/6 and this is it is Z value 4 के लिए 1/6. Total probability तो 1 होगा. If you total probability equals to 1. Now, once you got the probabilities, now you are ready to find the entropy. H of Z will be equals to summation I. This is PZ I log this is 1/PZ. All the options are given in bits per symbol, so the base will be 2. Finding entropy base will be 2. If you don't want to write log 1 upon PZI, then you have to write minus here. If you write minus here, minus some PZI log PZI. Do this. Yes. So in finding the entropy, we consider only probabilities only. Is 1/3 log 3 base 2 plus 1/2 log 2 base 2 plus 1/6 log 6 base 2. How much you got? Try with calcium. This is 1.45 you will get. Success. 1.45 bits per symbol. So option C will. Okay. Good. Most of you given correct answers. Good, Sonali and yeah, Bhushan, Ashish, Shawali. Let's this question now. Try this one. Okay. Now, an information source consists of 128 symbols, 112 of which occur with a probability 1 upon 220. Okay, and the remaining 16 occur with a probability of 1 upon 32. Among these 128 symbols, 112 symbols occurs with the equal probability of 1 upon 2. Remaining 16 symbols, okay, remaining 16 symbols will occur with equal probability of 1 upon 32. Now the source emits 1000 symbols per second. The value of S by N in dB required so that the output of this source is transmitted without error over an AWGN channel with a bandwidth of 2 kilohertz, at least of how many dB? It is given in dB, no need to mention. So that S by N should be at least of how much? Okay. So here, what you can understand here is if you read the question properly, there is one model of question. Here a source is there, it is emitting some symbols. Some 128 symbols are available with the source, 128, x1, x2 up to x128 like that. 128 symbols are available with this. Among this 128 symbols, the probabilities associated with the symbols also given. And the source is emitting 1000 symbols per second. It is emitting how many symbols? 1000 symbols per second. Okay. The value of S by N in dB required so that S by N in dB so that output of the source is transmitted without error over an AWGN channel. This output of the source is transmitted through AWGN channel now. The output of the source is transmitted through AWGN channel. Okay. Without error, without error. So for that error free transmission के लिए, without error mean error free transmission के लिए, okay. So the channel bandwidth is also given. Channel bandwidth is 2. Channel का bandwidth कितना है? 2 kilohertz है. So the output of the source is transmitted through AWGN channel where the available channel bandwidth is 2 kilohertz. Then for error free transmission के लिए S by N should be at least of how many dB we need. So error free transmission के लिए C should be greater than or equal to RP. This is very famous result. So whenever in the question, if you see a phrase like this, error free transmission, immediately you have to get the strike of this. Error free transmission के लिए C should be greater than or equal to RP. Okay. Now how to find RB here is, how to find RB? How to find RB? Bit rate of the source. How many RB bits per second? How many bits generated in 1 second from the source? Good question. Solvable, but good one. So when the source is emitting the symbols like x1, x2, x3, like it is emitting the symbols like this, symbols. Okay. एंड सिंबल्स को ट्रांसमिट करने के लिए आपको याद है तो इन्फॉर्मेशन थ्योरी, इफ यू रिकॉल इन्फॉर्मेशन थ्योरी, शैनन फाइनर कोडिंग, हफमैन कोडिंग, सिंबल्स को ट्रांसमिट करने के लिए वी हैव टू डू कोडिंग करना है. एवरी सिंबल वी नीड टू रिप्रेजेंट विद यूनिक बाइनरी कोड. Okay, based on the associated probabilities associated, we can do coding. Okay, by using different source coding techniques like Shannon Finer coding technique and Huffman coding technique, like x1 maybe some code like 0, x2 maybe 1, 0, 1, like okay. Based on the probabilities associated, we do coding like this. Coding, some coding will be done. We represent with a binary codes. Okay, and once you represent it with binary codes, you will get a binary sequence. Okay, binary sequence milega, that binary sequence, okay, that bits which are produced, that binary sequence will be transmitted. So here आपको याद है तो this bit rate RB is equals to, when the source is emitting the symbols like this, then in this coding process how many bits altogether, how many bits produced in 1 second, that is we call as bit rate of the source or information rate of the source. That is RB is equals to, the formula is L into, where L is the average code length. Averagely each symbol represented by how many bits, but L is not given in the question. So इस symbols को coding करने के लिए क्या coding technique use करना है, that coding technique was not mentioned. Then we can't find L को, we cannot find without knowing the coding technique name. You can't find L. L is not given. The default L is L minimum only, and L minimum equals to H. This is one formula we have. So then RB equals to H into the formula. How you can find bitrate RB? Okay. Yes. I'm just waiting whether any one of you can give the answers for this, but no one is giving. I thought to give you some time, but no one is giving. Fine. So if you find entropy first, H. So entropy is summation is Pxi log 1 upon Px base 2. This is, and this is bits per symbol. So to find the entropy, we need only probabilities. We can here 112 symbols occurs with the probability of 1 upon 224. Px1, suppose if you 1 upon 224, I'm taking, and it is log 224 base 2. And Px2 also, this is same 1 upon 224, because here 112 such symbols are there, and which are getting emitted with the probability of 1 upon 224. Okay, so 112 such symbols are there, so into 112 you will get. So again, Px2 log 1 upon Px2 also same expression, Px3 log 1 upon Px3 also same. So such expression you can expect for how many symbols here? 112 plus, and remaining 16 symbols occurs with probability of 1 upon 32. Okay, so if you see P, it is 112 symbols, P1, P2, P3 up to P112 is 1 upon 224 only. You take P113, 113th symbol that is occurring with probability of 1 by 30. It is 1 upon 30 log 32 base 2. And how many such symbols are there? 16 symbols are there. 16 such symbols are there. If this will be equals to, so try to do that. It comes to be 6.403. You will get 6.4. I can write. Units of H will be bits per symbol. Okay. Then bit rate RB will be equals to H is equal 6.4 bits per symbol times 2. Small r here is the symbol rate. You can understand how many symbols produced in 1 second. Symbols per second. Symbol rate. This is 6.4 times 2. So H is small r. How many symbols produced in 1 second? 1000. This is, I can say this is 6,400 bits per second at 6.4 kbps. You will get. Okay, 6.4 kbps. So then for no information loss scale, for error free transmission scale, what is the condition to be satisfied? C should be greater than or equal to RP. C is equal to V log base to 1 plus S by N. It is greater than or equal to RP. The bandwidth is given how much here? 2K is given. Base 1 plus S by N greater than or equals to RB. Bitrate RB, how much you got? 6.4K you got. So it is log base to 1 plus S by N greater than or equal to, it is 3.2 you will get. Then it is 1 plus S by N greater than or equals to 2 power 3 point, then I can say S by N greater than or equals 2 power 3.2 minus 1. This is 8.18 you will get. Try with calcium. 8.18. In options are given in dB. To get in decibels, it is 10 log, I can say 10 log 8.18. This is, if you do this 10 log 8.18, this is 9.13 dB. S by N greater than or equals to 9.13 dB. So I can say S by N should be minimum of, should be at least of 9.13. Do check once again. This is yeah 9.1. So this is 9.13 dp will be the answer. 9.1 you can write. You round off to one decimal place. 9.1. Is good, John and Shavali, correct answers. There are few questions like okay, I can discuss within the allotted time. And some more questions also there. The questions like related to finding optimum threshold by using map theorem, ML theorem, finding optimum threshold, and finding probability error by using map and ML theorem. We already done several questions based on those. That model of questions also you can expect. Finding optimum threshold. You remember na? 8th unit as the last unit I solved those questions. Finding optimum threshold, okay, and finding minimum probability of error by using map and ML theorem. And to find minimum probability error by using map and ML theorem, again shortcuts also. वो shortcuts को भी आप use कर सकते हैं. That is as in 8th unit I discussed those. I'm not taking up those questions. The questions I can discuss a lot of time. Like so many questions, like there is no time limit. We can go on solve so many questions, but try to stop somewhere and go through that 8th unit also. Those topic I haven't covered. Just go through those topics. Just go through the workbook of 8th unit, or you can go to the regular classroom notes also. Once you do revise that, and like so one of your friends already asked like which one should be given a priority. Hamming code, that is Hamming code is linear block code only. No? Jan Abraham, you are saying error detection correction by using linear block code, which is also called as Hamming code. So that is with the help of syndrome you can do that, no, Jan Abraham. We done several questions on that. First you need to find syndrome to do error detection correction. Syndrome you have to find out. So that is R into H transpose, that will give syndrome. R is the received code word. So received code word को हम we have to decode that received code word. If they will give a received code word and if which errors hai to we have to detect and correct that errors and we have to get original transmitted code word. That is what we call as decoding of a received. Okay, what is the procedure? First you need to get syndrome. This is R into H transpose. So you will get some syndrome matrix milega, and you have to compare that syndrome. You have to check whether syndrome is matching with which row of H transpose. H transpose matrix will be there, no? H transpose matrix will. You have to check that the syndrome is matches with which of the rows of H transpose. Syndrome what you got is matching with which row of H transpose. You have to check that. If syndrome suppose is same as the first row of H transpose, so directly ये मतलब है कि error is in first position. The syndrome what you got is same as the second row of H transpose, so ये मतलब है कि error is in second position of received code word. In that way you can detect and correct that error. Okay. Yeah, Devash Pandey, if any such doubts hai to um, just give me a message in the Telegram, personal message in the Telegram, or just in the group, give a message. So I will, in which topic you are looking for more questions, so I will try to give that questions in the Telegram. Okay. Yajan Abraham, Devesh Pandey. Okay. If you're facing doubts, if you're facing problems in solving any model of questions, try to mention that in the Telegram group. और टेलीग्राम ग्रुप में आप मैसेज कीजिए और पर्सनल टेलीग्राम आईडी पे भी आप मैसेज कर सकते हैं, कैन डू, आई विल डेफिनेटली हेल्प यू फॉर. Okay, if you post it in groups, so I created groups in Telegram groups. If you post in the Telegram group, even your friends also can help you. If you want some more questions on a specific topic, I will give you that questions. Which topic you are looking for more questions, I will post that questions. Okay, Jan Abraham and Devesh Pandey, okay for that? Okay. So okay guys, I hope you enjoyed this session and आपको कुछ मौका मिला है go through some questions. These questions I took questions such that I just thought to revise the what you learned in the regular classroom. In that direction only I given the questions. I have not given very out of the box questions. I have not given. So otherwise, because your confidence will, I don't want to demoralize your confidence. So within the reachability only, I framed the questions. Hope most of you given correct answers only. I'm happy for that. Okay, I'm expecting this session will help you in the coming GATE examination. All the very best, guys. Thank you so much. No, I can't say that, Sai. Higher level, I can't say that, but a few questions, one or two questions, a bit of higher level, one or two questions. Most of the questions will be in this level only. 1-2 questions maybe of higher level can be.